Now, this part of section 3.3 is a little bit different, but I want to make the connection between polynomials and real numbers. Okay, so we've dealt with a lot of real number scenarios. And when you're first starting out, you start on a real basic understanding of adding and subtracting numbers. You start just the way we did with polynomials in terms of calculating. So you might have started out with like taking what's 6 plus 5? And you'd say, well, what is 6 plus 5? And your elementary school teacher would give you some problems like that. You know, what's 6 plus 5? Or what's 3 minus 8? Again, your elementary teacher could have given you addition and subtraction problems just like that. And obviously you'd fill these out and you'd 3 minus 8, negative 5, 6 plus 5 is 11, etc., etc. And then once you get a little more sophisticated, let me adjust those. You could say, well, let's find two numbers. Let's find two numbers which add to 10. And you'd say, well, there's lots of different pairs of numbers which add to 10. In fact, that's kind of like solving a linear equation in two variables that says x plus y equals 10. Let's find an ordered pair x and y which add to 10. But there's lots of different pairs, right? You could have said, well, 2, 3 isn't, not 2, 3, did I say that right? 2, 8 is an ordered pair which adds to 10. There's obviously other ordered pairs that add to 10 as well. 9, 1 is an ordered pair that adds to 10. Negative 3, 13 is an ordered pair that adds to 10. All right. So you start out doing calculations in terms of addition and subtraction, and then down the line you start figuring out numbers which add to 10, or in the more sophisticated view of this, you have two variables which add to 10, and you can sort of find the missing number type questions as well. Now that I know how to add and subtract real numbers, I can ask myself, well, if I have 3 plus blank is equal to 7, what's the blank have to be? And you'd say, well, obviously the blank has to be 4, right? So that's the idea. Whoops, undo that underline there. There we go. So the number in the blank has to be 4. And again, in a more sophisticated way, we can say, well, 3 plus t is equal to 7. What's t equal to? And obviously we can solve that and say t equals 4. Now, I say all that just to remind you that polynomials are just numbers of certain types. So now that we know how to add and subtract polynomials, we can use those polynomials to solve equations. In fact, this t equals 4, you could think of this number t, or this variable t, as a polynomial. Specifically, the polynomial we need to plug in here is 4. You can think of this x and this y as polynomials. And you say, well, we have lots of choices to plug in for x and lots of choices to plug in for y. So once we know how to calculate, add and subtract numbers, then we use those facts to solve linear equations, either in one variable or in two variables. And that's what we're going to do with polynomials as well. Now, this starts out by just noticing that in the two variable equation types, there's lots of pairs which add to the same polynomial. If you check this 9x minus 3 and negative 5x plus 1, add those up, you get 4x minus 2. Well, if you take negative 2x minus 14 and 6x plus 12, add those up, you also end up with 4x minus 2. So there's lots and lots of different combinations when we get to those problems where we have to find an ordered pair that works. There's lots and lots of pairs of polynomials which are going to work. All right. So we're going to try to see polynomials as solutions to equations, and in particular, solutions to either two variable equations or one variable equations. Now, I'm going to start with questions 3 and 4 and 5 of the instructor-led problem because I think they're a little bit more straightforward. And then we're going to move on to questions 1 and 2 of the instructor-led problems. So let's take a look at problem 3. Let me give myself a little bit more space there on the Word document. It says there is a polynomial p such that 3x minus 2 plus the polynomial has to be 7x plus 5. So let me copy that equation. There we go. So the goal here is to find p. Find what this polynomial we add up is. And there's a number of ways we could go about doing this. The easiest way I think that we can do this is to look back at section 1(3) for inspiration. When we were solving an equation that was 3 plus t equals 7, what did we do? Well, hopefully you subtracted 3 from each side. Whoops, I'm sorry about that. I was on the wrong. So hopefully you went subtract 3 from the left side, subtract 3 from the right side, and that's how you ended up with t equals 4. All right. Well, we're going to do the same thing in terms of this polynomial, or excuse me, in terms of this problem here. We're going to say, well, what we really need to do is get rid of this 3x minus 2 on the left-hand side. And we're going to do it in one single step. We're going to subtract 3x from the left side. We're going to add 2 on the left side. Now, if I do something to the left side, like subtract 3x or like adding 2, then I have to do that on the right side of the equation as well. So we're going to add 3x to both sides. We're going to also, did I say add? Subtract 3x from both sides and add 2 to both sides of that equation. All right. Now, if we do that, what's going to happen is the 3x is going to cancel, subtract that. You're going to end up with a 4x on the right. And if I add 2 to both sides of the equation, we end up with a plus 7 on the right. So you end up with p equals 4x plus 7. Again, what we're trying to do there is balance things out, but move all of our terms that are not p to the right-hand side. So that requires us to get rid of 3x. That requires us to get rid of this subtraction of 2. Did I say so? Get rid of the subtraction of 2? Get rid of the subtraction of 2. So when you get rid of a subtraction, you have to add. When you get rid of a positive number, you have to subtract. So there we are. So 4x plus 7 is the polynomial that you would need here. Again, this is just like solving a linear equation. Now, problem number 4 is the same way. It says find the polynomial such that this happens. X squared plus 12x minus 24 plus the polynomial is equal to 4x to the 5th plus 9x plus 2. Now this one's a little bit trickier than the previous problem. Not crazy trickier, but conceptually it's the same, but you do have to watch out for one little little wiggle here. Just realized I copied that down wrong. That should be a negative 4x to the fifth plus 9x plus 2. Negative 4x to the fifth plus 9x plus 2. So here's the deal. What's the thing we need to watch out for? Well, the thing we need to watch out for is that x squared and x to the fifth are not like terms. So when we go and start canceling things on the left-hand side, when you do a minus x squared minus x squared, that does not combine with the x to the fifth. Now, when you subtract 12x from the left-hand side, that will combine with this 9x. So subtracting 12x from both sides will combine with the 9x. And by the way, adding 24 to both sides will in fact combine with the adding of 2. All right? So that's the idea. So when you do this, you're going to get minus 4x to the fifth. Subtract 12x from both sides, you end up, I'm sorry, let me go. When I said minus x to the fifth, that's what I'm saying is the first term on the right. Subtract x squared, you get minus x squared. Subtract 12x from both sides, you end up with a minus 3x. Add 24 to both sides, you end up with a plus 26. So the polynomial that you need to deal with, or that you're looking for, is what I should say, is minus 4x to the fifth minus x squared minus 3x plus 26. Okay, it's important that you do not combine these first two terms because those first two terms are not alike. Similar approach, or actually the same approach to question 5, we end up with this linear equation, linear in terms of p anyways. And so what we're going to do, I'm going to, in this, you know what, I'm going to do this way. Let's type this in. We're going to subtract 4x squared from both sides. Hopefully that's not too hard to follow. We're going to add 6x to both sides. And then we're going to subtract 10 from both sides. So we subtract 10, we add 6x, and we subtract 4x squared from both sides. Now, I'm going to put the polynomial on the right in descending order. So on the left, you're just going to end up with p. On the right, if I put this in descending order, I get minus 4x squared plus 6x plus 7. All right, that's 17 and the minus 10 combined to give you a plus 7. Hopefully that's all right to watch and see. So that's how we can solve for a polynomial. In fact, all we're really doing is solving for a variable p here. And that's a skill that's going to be really nice when you go into higher and higher up math courses. Being able to move things around at will and solve for a variable. In this case, our variable, the solution happens to be a polynomial. All right, so then I'm going to move back up to problems 1 and 2. These are a little bit more mushy in terms of solutions because it turns out there's lots of different solutions to problems 1 and 2. It says, give an example of two trinomials whose sum is 14. So all we're looking for is two polynomials, polynomial 1 and polynomial 2, which add up to 14. Now, instead of writing these as polynomial 1 and polynomial 2, I'm just going to write these as capital A and capital B. So two polynomials, we'll call them A and B, which add to 14. Now, the only caveat about what type of polynomials is that they need to be trinomials. So let's make a trinomial. So I'm going to replace a with some trinomial, maybe x squared plus 14x plus 9. If I replace a with a trinomial and I just leave b the same, you can see that by solving for b in this case, we're going to end up with two polynomials, one being x squared plus 14x plus 9, and another being whatever it comes out to be, which add to 14. So that's how we like to do these types of problems. We like to just say, well, let's take, and since this one needs to be a trinomial, plug in any trinomial you want. Now it does have to be a trinomial, so these terms do have to be ones that are not alike. And by that, I meant if you did like 12x plus 14x, that's not a true trinomial because that can be simplified into a binomial. So you do have to have three terms which are not alike in order to have a trinomial. But once you've done that, then we can solve for b in the way that we did in problems 3, 4, and 5. So what you would do is you would subtract x squared. Let me write that down. So you'd subtract x squared from both sides, then you'd subtract 14x, then you'd subtract 9. You do that to the left side, and then you'd also do that minus x squared minus 14x minus 9 to the right side. All right. And what you would end up with is b equals minus x squared minus 14x plus 5. Now, b equals this polynomial is not the actual answer. Remember, we wanted an example of two trinomials who sum up to 14. So here was one of them. The other one was this one. So what we would say is that the trinomials are, or at least the ones that we're thinking of, are x squared plus 14x plus 9 and negative x squared minus 14x plus 5. All right. And so those are two trinomials which add up to 14. Now, again, my choice of A here is arbitrary. You may have picked a different trinomial to start out with. And if you pick a different trinomial to start out with, that is perfectly fine. You can start out with almost any trinomial you want and then solve and get a trinomial as your B. So your choice of that original trinomial is very squishy, meaning you can choose whatever you'd like. All right. So there's no real terrible answer for our first choice of trinomial there. Let's go ahead and do number 2. Find an example of two binomials whose difference is 5x plus 2. Now, normally, difference means that you subtract them and you get 5x plus 2. But since we've been adding all these polynomials, I'm going to change this. I'm going to strike out difference. Okay. I'm going to change that to a sum. So I want you to do that on your papers too. Just draw a line through difference and say sum is 5x plus 2. And then we're going to write a plus b is 5x plus 2. Now, once you go ahead and do that, then it's just a matter of let's choose some polynomial for a. By the way, this one has to be a binomial, so it has to have two terms. Let's choose a binomial for a, maybe 8x plus 10. That's fine. If you chose something different, if you chose 3x minus 7, that would have been fine too. Your b would have been different, but that's all right. All right, so what we're going to do, we're going to subtract 8x from both sides. We're going to subtract 10 from both sides. So subtract 8x, subtract 10 on the left, subtract 8x, subtract 10 on the right. You end up with, on the left-hand side, just b. On the right-hand side is a negative 3x minus 8. By the way, the one thing I probably would like to avoid is I'd like to avoid zeros, because then I wouldn't have a true binomial. So in order to avoid zeros, you just pick numbers that aren't here. So I would never pick 5x plus 2 as my a. I would never pick a 5x and a plus 2, because if I chose plus 2, I'd end up with a 0. If I chose 5x, I'd end up with a 0. But other than that, your choice of a can be anything you want. All right, so the answer here, the two binomials are, well, what did we have as our first as our a? That was 8x plus 10. And what did we have as our b? That was negative 3x minus 8. Oops, I forgot to write that in math print. So those two binomials add up to 5x plus 2. Again, make sure we scratch off difference there and wrote sum. So that's the idea. That's the idea of using these polynomials, using the letter P or the letter B as simply a variable. And these polynomials, we treat them algebraically just like we do numbers. So we can solve for them just like we solve for numbers. Excuse me, I meant solve for any other variable. So we solve for a variable, which is a polynomial, solve for P, just like we solve for any other variable.